And for our team key challenges and AR navigation requirements, we need to start with environment sync gap. In traditional software, a 50 millisecond lag is a nuisance. In AR navigation, it's a safety failure. Our research identified that current elicitation techniques don't sufficiently capture how a system should behave when a digital object blocks a real-world hazard. This leads directly to cognitive and physical safety. We've seen that users can suffer from digital tunneling. So when they're trusting in the AR path so much, they won't be looking at the actual street. The challenge for requirement engineer is to find how to limit cognitive load so the user can stay safe. Finally, we have to address the usability safety paradox. In most graduate projects, usability is a non-functional nice-to-have. In AR, if the UI is blurry or misplaced, the consequences can be lethal. So we are arguing that AR requires a shift from static requirement to dynamic scenario-specific requirements that can adapt to a user move from a quiet indoor hallway to a busy outdoor intersection.
Motivations. This research is driven by growing safety concerns in AR, including motion sickness, physical strain, and cognitive overload. AR adoption is accelerating, but requirements engineering hasn't kept up. Current technologies like BLE, UWB, and SLAM have limitations, especially indoors and in dynamic environments. There are also gaps in auditory feedback and real time behavior modeling. More importantly, critical factors like visual clarity are misclassified as non functional instead of safety critical, so a new elicitation approach is needed.
So, to address how industry practitioners have tried to move forward with these challenges, firstly, what they have done is gather data, and what this data does is highlight some specific safety issues, which includes motion sickness, physical strain, and mental health concerns. They've also improved visual enhancements in the interactive experience of their users. This looks like standardizing some safety protocols, providing comprehensive training programs, consensus building efforts to establish guidelines, and just encouraging the responsible use of AR technologies, including in different settings. They've also advanced their Bluetooth Low Energy Beacon, so BLE. This uses Bluetooth wireless transmitters. They've introduced ultra wideband, which measures the radio waves, and then advanced environment interpretation, so sensor fusion or VSLAM. Just some additional examples are SLAM, so simultaneous localization and mapping, adding more cameras and sensors to their technology, and then cloud anchors and 3D mapping. What they have not done is focus on auditory aspects. So, what that's done has neglected one of the senses that work together in the human experience. So, that's a very underrated thing that many companies have not really paid attention to. There's also, just in general, a lot of shortcomings to indoor wayfinding. Additionally, what happens during the software early development process is that visual clarity can easily end up assigned as a non functional UI preference rather than being functional, which can be a huge deal because if you cannot see through the AR technology, that could possibly cause a lot of lethal mistakes and deaths. They also have not really have a space for like real time dynamic requirements. So this means like post coding, the requirements should be able to change depending on environments, and this would mean that the requirements have to make up for a lot like different weather, different ways people function, and that's just a hard thing to include in the elicitation process. So those are the things that they would need to address to just try and make the field safer for people and make AR navigation more efficient and usable.
Industry already addressing AR safety challenges. Industry practitioners have started addressing AR related risk by studying issues like motion sickness, physical strain, and mental health impacts. Adoption of advanced technologies. Technologies such as Bailey beacons, ultra wideband, SLAM, and sensor fusion techniques like VSLAM are being used to improve positioning and environment understanding. Standardized safety protocols and training practices emerging. There are also efforts to introduce safety guidances, training programs, and standard practices to ensure responsible use of AR systems. However, important gaps still remain, especially in areas like auditory feedback, indoor navigation accuracy, and handling real time dynamic conditions. In some cases, critical aspects like visual clarity are treated as non-functional UI preferences when in reality they can directly impact user safety. This highlights the need for improved requirement engineering approaches that are specifically designed for AR navigation systems.
For the scope of our research, we narrowed things down to specifically techniques or methods for eliciting requirements regarding safety in AR navigation systems. So we wrote these three research questions here to sort of guide our research in our paper. The first one is, to what extent do traditional hazard elicitation methods need to be modified to account for the failure modes that are unique to AR navigation? So this sort of acknowledges that there are some methods that are used more traditionally for hazard elicitation that could still be applied to AR navigation systems, but there could also be some new methods that need to be created to address some of the unique challenges that come with augmented reality systems. Our second research question is, how should requirements engineers elicit safety requirements for AR navigation systems that must operate across multiple distinct environment types within a single use session? So traditional software systems might not necessarily need to account for this, but AR navigation systems could be used indoors or outdoors in different lighting conditions and all these different environmental situations. So we need to be able to elicit requirements for specifically systems that need to be used across different environments in the same session. And lastly, our third research question is, what elicitation techniques are best suited for capturing cognitive load thresholds from end users? So cognitive load, we don't want to overwhelm the user too much with the user interface. The navigation system should be helping the user rather than interfering or impeding their ability to interact with their environment. So what techniques are best for measuring cognitive load? What thresholds of cognitive load are most reasonable in terms of safety? These are all things that we want to understand better in our research.